Hey guys, I'm Sam. That's my solar powered car, the Sun Eater, and this is a YouTube channel where we look at all aspects of how to add solar power onto our vehicles. Today's episode is going to be about probably the most common question I've been asked since I started this project about a year ago, which is why don't I just run the power straight from the solar panels to the main vehicle battery? If you look back here, I've got all this other crap. We've got the AC unit, the inverter, and all these batteries. They take up space, they add weight, and most importantly, they cost money. So why haven't I found a way to just bypass all of this and run the power straight to the main battery? I'm going to look at, in the course of this episode, attempts that have been made by people from really all over the world to do that with this vehicle, what some of their successes have been, and what some of the setbacks and pitfalls are. And I'm going to kind of try and tell the story of why I started out using this method and why this system will probably evolve to incorporate some kind of module that takes the solar power and turns it straight into a form of power that our main vehicle battery can charge off of. And at the end of the episode, I'll even do a Zoom interview with the one person that I know of that has been successfully able to solar power their car without having to mess with all this stuff back here. But before I get started on the main topic of the day, I'm going to do my weekly update like I always do. We haven't been able to set any new kilowatt hour records. I'm still stuck at that 3.2 that I was last time, but I did a few days ago set a new peak charging power of 492 watts using this system. Just shy of half a kilowatt, which is good, still making improvements there. I'm hoping to add more onto that. Now, I used to have solar panels mounted directly onto the roof of the vehicle, and you guys probably remember at the end of the last episode, or 2 episodes ago, after I went back through and built this reinforced roof rack right here, it was casting these little 2-inch bands of shadow on the panels that were on the roof, and I thought I'd noticed a pretty kind of sharp downtick in the amount of power that the overall system was putting out. But I was hesitant to go through all the trouble of moving them and lifting them and everything. It didn't seem like that little amount of shade could really be stealing that much power from the vehicle. And it's kind of hard when you look at your charge controller at the end of the day and see how much power you've gotten overall. It's kind of hard to figure out if you've got individual panels that are failing you or not. So that might have been where I left it. But fortunately, I've got some pretty awesome patrons of the channel that help me fund these little experiments. And I used some of their donations to buy this little watt meter right here. And when I cut one of these panels off and lifted it up above that shade, I couldn't believe that the amount of power that panel, that 100-watt panel, was putting out doubled when it was lifted above the roof rack and set on those little supports. So I took some pictures of the watt meter hooked up to those 100-watt panels in both positions, one with the panel on the hood, one with the panel on top of the rack where it wasn't in any shade. And I got pictures of the reading going from 40 watts to 80 watts. You can check those out on my Patreon page. I'll put a link in the video description. It really was pretty eye-opening to me to see how we can lose up to 50% of our power, even with only about 15% of the panel actually in shade. And I think there's probably a pretty valuable lesson there that people who are planning their own home solar arrays can take away. Maybe that patch of roof that you had in mind for a solar array that gets, just a little bit of shade from the tree nearby seemed like a good idea, but after you go back and look at how much loss a little bit of shade can cost, you want to rethink your location for that. Okay, so our panel still folds out without too much trouble. So our 200-watt panels are bolted onto little aluminum supports that I ran right on the truss of the roof rack here. And because these hinges are so thick, the 175-watt panels on top of them can slide over that. So when we fold it out, everything gets full sun now. There's no partial shading of these 100-watt panels because they're underneath the roof rack. And that gave me that doubling of the power from those 100-watt panels that we saw. And it also provided the added benefit of keeping the vehicle in the shade because it's underneath those solar panels. Solar panels get hot in the sun, really hot. 153 degrees. And if you've got that mounted straight onto the skin of the vehicle, like we do with this one on the hood, that's basically 150 degree little heater that you have resting straight on the surface of your car. So if we come over here and look at the surface temperature of the vehicle right here, we can see it's 132 degrees. But if we take the same reading underneath the shaded area over here, it's only 113. So we've got a 20 degree difference in surface temperature by lifting those 100-watt panels up off the surface of the car, putting them on that roof rack, and effectively shading the whole roof of the vehicle. Cutting the panels off of this area right here and lifting them up onto that roof rack also freed up a pretty good patch of space right here. There's a lot of power that falls on this part of the car, especially in the morning, and I think I can fit an extra 100-watt panel there. I'm also in talks with a company that makes custom solar panels to see if they can make us a custom panel that will fit this area of the hood and add a few watts there. And I think after those two steps, I think we will pretty much maximize the amount of solar power we can get just off the top of the vehicle. And at that point, we'll look at maybe some low-hanging fruit like solar panels for the sides of the car, and do those actually do anything? Okay, another question I get all the time that I haven't talked about in a while is people always ask me about the efficiency. How much adding the solar panels and the weight of the batteries and all that in the hood has affected the fuel economy. And if you look right here, that number was 4.7 miles per kilowatt hour when I first got the vehicle and didn't have anything in it. And it's 4.6 now. So really surprisingly, even with the weight of the batteries and the solar panels, we're only looking at about a 2 to 4% efficiency loss, which would wind up being something like 2 miles on the 50-mile range of the vehicle, and lost range due to loss of efficiency. But you're losing 2 miles from your loss of efficiency, and you're getting, 20 to 25 miles a day back from your backup batteries in the back and the solar on the roof. So really any losses that we have in efficiency are pretty minimal, especially compared to the gains in range that we get from adding, an extra 20 to 25 miles. Almost 50% of the range of the vehicle is added every day using this system. We've been able to put 7,586 miles on the car since I got it, which is pretty awesome, especially considering that this vehicle never had a range more than about 47 miles. So all of that driving has been made possible exclusively by the solar powered range extender. Additionally, driving that many miles in an ICE car would have cost us somewhere around $1,500. If you look at cost of ownership and fuel expenses, we paid $3,000 for this vehicle, and when we get done with it, it'll still have a battery in it that's worth about $1,100 on eBay right now. So if you add the $1,500 in savings plus the $1,100 in battery value, we're up to $2,700. We only paid $3,000 for the vehicle, so we're actually getting pretty close to getting the thing to pay for itself and starting to tip the scales in favor of us actually having saved money in the long run by buying this little electric vehicle and keeping it going. However, the battery is degrading. You guys know that I lost one of my battery health bars down there not too long ago, and I tracked the degradation of the main battery in this Leaf per miles driven on my Patreon page. I update that every couple weeks or so you can go look at how the battery is degrading over time. It is debatable whether or not we'll be able to get another 7,000 miles out of this battery. It'll be very interesting to see how it all shakes out when it's all said and done, and that we finally can no longer make our work commute on the battery that's in there now. We've got to drop it out and crunch all the numbers and see exactly how far out ahead or behind I came because of this little experiment. And I think that'll probably wind up happening here in the next 4 months, as your range in these old Leafs falls off a lot in the winter, and this old battery just won't be able to make the trek anymore. Okay, so that's enough on battery degradation. I'm going to take a look at one more thing in the back of the vehicle, and then we'll get on to the main topic material of the video. I went back and cleaned up the wiring a little bit. It's pretty easy to make custom lengths of this wiring. I got some little parallel connectors there. to kind of tie it all up in a nice neat little bow. I had one viewer ask me how specifically the panels are wired up. This is a 12-volt system, so every single panel on this car is in parallel. On these solar panels, there are indicators on the terminals here that'll say negative or positive. And from there, it's pretty easy to just run all your positive wires into one of these parallel connectors, and all your negative wires into one of the parallel connectors, and those just run to your main positive and negative on your charge controller. Easy peasy. I promise you, you can figure it out with minimal effort. Okay, that's it for the video update. I know it was a little long-winded there. Let's jump into the main topic of the video today. How can we take our power straight from our panels and put it into the battery so that we don't have to mess with all this stuff back here? All right, so on to the topic of the day. Can we bypass all this hardware back here and just run the power straight from our solar panels to our electric vehicle? I actually did a video about a month ago called the Solar Powered Smart Car, and in the comments section of that video, somebody sent me a link to a YouTube video where a guy does exactly that. He pulls up in his smart car. He's got a little conveyor of flexible solar panels that he pulls out of the top, and sure enough, right there on the top of the vehicle is one of these little J1772 plugs hooked into the reel of solar panels, and the guy takes it and plugs into the side of his car and walks off, and he's good to go. There's a few reasons that doesn't work. Pretty much all EVs, certainly the Leaf, have a minimum amperage that the vehicle's charging hardware will recognize when you plug it in. So my little car charger right here actually has 3 different settings I can set it to. It's got 8, 12, and 16 amps. If we plug in a 6 amp source, 6 amps of 120 volts comes out to about 720 watts. Well, it turns out that 720 watts is very, very difficult to generate using the amount of solar panels you can fit on a car. I mean, I've blanketed this thing pretty thoroughly, and as you remember from earlier in this episode, the highest wattage that I've ever hit is like 500. So hitting 700, especially on a smart car, honestly is just this side of impossible with the solar panels that we have today. Maybe 20 years from now, that'll be easy. But with the technology we have today, generating 720 watts on a smart car is pretty dang difficult. But even if you could generate 720 watts of solar power from the amount of panels you could fit on a smart car, that's the minimum required to charge it. And since there's no batteries at all in that system, anytime like a cloud goes over it or anything causes that solar power to drop off for a minute, well, this happens. Now, let's say you're generating your 720 watts of solar power and your car recognizes it. You're going to hear something here. Underneath the car, right then, you heard a little click. Those are the contactors closing on it. So now your car's charging, but let's say something like a cloud blows over and causes that solar power to drop off for a minute, as must happen dozens, if not hundreds of times a day. Your car ceases to detect the minimum 720 watts from this, and this happens. Just the mic. Now, you probably heard that contactor pop open again, and then the cloud blows over, and your car is getting the 720 minimum watts again, and again you hear that clicking. Now, these high voltage contactors in an electric vehicle are designed to operate in a very similar fashion as a starter in a gas-powered car. The contactor opens when you're not driving the car, because that contactor is what supplies that dangerous 400 volt power to things like the electric motor and other parts of the car. So just as a safety feature in all electric vehicles, when you turn the car off, the contactors come. When you turn the car off, or when you're not charging it, the contactors come open. But also like the starter in a nice car, the contactors are designed to work probably 4 or 5 times a day, just like the starter in your gas car. You know, once to get you to work, once to get you home from work, maybe an errand or two along the way. If you were to cycle that contactor on and off hundreds of times, as would happen when you had no batteries, you know, every time a cloud blew over your solar panels, your contactor has to pop open and reclose. You'd be cycling it dozens or hundreds of times a day, and you'd burn it out very quickly. So how do I get around this problem? Well, I've got my batteries in the back that soak up 5 hours of solar power, and then just run that car charger straight for 3 or 4 hours. And then they'll soak up another, the timer is set to turn off the car charger, and it'll soak up another 4 or 5 hours of sunlight and charge again for 1 or 2 hours. And in that way, I'm able to use all the solar power I get all day long, but only have those contactors close a few times. That would be another downside of a system without any batteries at all, is that every time that we're getting less than the minimum 700 watts necessary to charge the car, all that power just gets wasted because it just sits there and doesn't have anywhere to go. By adding batteries in the back of our car, those early morning sunlight hours where you're not getting as much power, those late in the afternoon hours like right now where you're getting a lot less, we can still utilize and store all that in our backup battery bank and then put it all into our main battery bank later. I hope that explains why the method of running your car charger directly off your solar panels through the J1772 port really probably would be a bad idea. Okay, so if the restrictive factor here is the actual charging hardware inside the vehicle that's limiting us to 6 amps, then we've got to find a way to work around that. Well, we know that underneath the car, there's the main connection from the battery to, you know, the cord that goes to the electric motor and powers it. What if we could build some kind of adapter that would go in between that plug? Well, then we could jack our power, our solar power, directly into that and run that into the main battery, and we would bypass this restrictive factor of the vehicle charging hardware over here. Well, about 3 years ago in Canada, there is a guy that did exactly that. Instead of using solar power, he had actually built a separate battery for the back of his vehicle that was actually made of recycled laptop batteries. He's got a pretty cool channel, and I'll put a link up here so you can go check out his channel if that's something you're interested in. And he was able to successfully get the power from his second battery that he built to flow directly into the vehicle's battery through his adapter. I'll put up a picture of it right here. And thus kind of extend the range of his vehicle by adding a second little battery on top of the big one. But he had the poor fortune to not know about a component in the Leaf called the Pre-Charge Resistor, and he had the humility and the honesty to document the rather unfortunate thing that happened afterwards, which was after he got to where he was going and successfully used his range extender, he turned his Leaf off, and this opened the contactors. And when your contactors are open, but you still have 360 volt power trying to flow into that open contactor, it burns out a component called the Pre-Charge Resistor. The Pre-Charge Resistor is designed to determine something's gone wrong in the battery, and like the contactors have maybe, the contactors on that switch that open and close have fused shut somehow. So there's a second failsafe called the Pre-Charge Resistor that burns out and disconnects your high voltage power. At least that's my understanding of it. But anyways, once you burn that out, your car is dead ski. So the guy up in Canada that has the Leaf X-Pack YouTube channel wound up having to get his car towed from that location. So the presence of the Pre-Charge Resistor in the vehicle gives us one of two options. Either one, and this is the complicated one, we've got to find a way to hack into our vehicle and get those contactors to close when we want them to, i.e. when we are applying our solar power to that battery and charging it that way without it being plugged in. We need to hack the vehicle and trick it into charging those contactors then. That's, I think, the harder way. The other way is you can actually open up the battery pack, and attach leads inside the battery pack behind the pre-charge resistor, and that gets you direct access to the inside of that battery, and there's nothing standing in between you and taking solar power and potentially putting it directly into that battery. I've got a friend in Houston, Texas, who's somewhat of an expert at connecting the leads to the inside of the Leaf battery pack, having done it several times. He uses these leads to connect another full-size Leaf battery that he puts in the trunk of the vehicle. I personally don't want to put another battery in my Leaf for reasons I'll go into in another video, mainly heat-related degradation, but I am very interested in his method in attaching leads to the inside of the battery, as it gives us an access to potentially directly charge the main battery without encountering any of the problems mentioned previously in this video. At first I was hesitant to try and charge the battery while the vehicle was turned off and not plugged in. I watched a video of a complete teardown of a Leaf battery done by the YouTube channel Weber Auto, and he mentions in the video that inside the vehicle service manual, Nissan says if a module is removed from the battery, it must be replaced with one at the exact same voltage. I interpreted from this that if the vehicle BMS monitors the battery voltage from the time the vehicle turns off to when it turns back on, and there's a difference, that it would cause problems. But after Shinoki finished his build, he did another experiment that makes me think we can charge the vehicle while it's turned off. He hooked up a device to the now exposed leads of the battery that turns 120 volt alternating AC grid power into the 400 volt DC power needed to charge the battery. He charged the vehicle this way, and with the vehicle turned off and not plugged in, as far as the vehicle knew, and it did not result in any problems. So it looks like we can charge our battery while the vehicle is parked, turned off, and unplugged, and it'll still operate normally. So voila, we figured it out. All we have to do is drop the battery out of there, open up the 400 volt battery pack, attach some high voltage leads to the terminals of that battery, reseal it, put it back under the car, and pull the leads up through the trunk here, and attach those to a module that will change our solar power voltage into the 380 volt power that we need to charge the Leaf, and we're done. And that way we can get rid of all this stuff back here. By this point you've probably realized why I started out with this method right here. Trying to open the Leaf's battery pack and attach the leads to it is a pretty advanced DIY project. And you are working around 400 volt power, which can be done safely, but is honestly a little dangerous. You have to buy special gloves that allow you to touch the terminals of a high voltage battery. Whereas going this route, the only even remotely dangerous part is the 120 volt power right there that flows out of the inverter. But our inverter is not powered up, it's not connected to the batteries. When we build the 120 volt ground bypass, so there's no real risk of you getting shocked there. It's just, this is a lower skill level is required to do this, versus opening the battery pack, which is a more challenging project, but it's a lot more efficient. That would allow us to turn our solar power directly through a DC to DC step up into the power that we need to charge the battery. By doing it this route, I'm running it through this inverter right here and the other inverter inside the vehicle, and each one of these probably eat 5 to 7% of my power when they go through that inversion process, converting it from AC, the DC of the solar panels, to AC, and the inverter in the car changing it from AC back into DC. We lose probably 10 or 15% of our power that way. So while the other route would be more challenging, it would also be a lot more efficient and allow us to get a lot more range in one day, because we're not losing our power to these inverters. It would also be a lot cheaper, because we wouldn't have to buy the batteries, wouldn't have to buy the inverter, wouldn't have to buy the AC unit. All we would have to buy is the solar panels, the charge controller, and either buy or build some kind of module to convert the solar panel voltage into the 380 volt power necessary to charge the battery. It'd be a lot cheaper to skip all these parts here. And it would apply to a lot more people's situations too. When I took a look at Jose's smart car from a couple videos ago, he's parked in the sun at his apartment complex all the time. He only needs a few miles a day. He doesn't really need a range extender that he can carry around with him. He just wants something that's going to give his vehicle a few extra miles of range every day. And if he could hook up an adapter to the solar panels on the car that would directly charge the high voltage battery, he wouldn't have to worry about all this, which is really what he needs. It's what most people need that contact me and ask me about putting solar on their vehicle is there some way I can add just a few miles a day? I only need 5 or 10 miles a day. I don't need a portable charging station. I would just like to, I don't have a convenient outlet, and it would be real nice if my car would just charge itself, even just a couple miles a day while I'm parked in the sun, is something that I hear a lot. Whereas the system that I've built, that I love, it's nice. I can go out camping or to the lake or anywhere, and I can have a power source with me that I can power anything I want to off of. It serves as a nice backup generator to the house if power goes down. I like having the option to power other things with my car, but the most common need that I get isn't for all this. It's really just for a few miles of solar charging a day. What would really make this accessible to people is if there were a method where we could take our solar panels and run it through a module to charge the car, but without having to drop the battery pack out, open it up, and go through that kind of fairly advanced DIY project. And I've actually found somebody who's pulled off exactly that. James, at the Real Solar Cars YouTube channel, has actually built his own device, his own circuit board, that he's installed underneath the hood of his Chevy Volt that takes solar panel from 2 solar panels that he has on a roof rack on the car and runs it directly into his vehicle. He's figured out which wires under the hood run power into the high voltage battery and which ones tell the contactors to close. And this board taps into those contactors and the high voltage battery, and he's able to charge his car off the solar panels without having to drop the battery pack out of the car and open it up, without having to mess with building his own solar power station in the back of the car. All it is a roof rack, panels, and a little board that's attached underneath the hood. And that's really exciting, because I think if we see a commercialized kind of kit, like when I envision something that you go to like an AutoZone and pick off the shelf, I think that's what this is going to wind up finally manifesting in some kind of like mass-produced commercial product as. It's something that people can just install under the hood, and they put some solar panels on the roof rack, splice into a few wires, and that's it. I think that'll have the most appeal to the highest amount of people. And so it's really cool to see someone kind of pushing all this in that direction. So that's why I'm so excited about what he's been able to accomplish. I actually got a hold of him and did a little interview with him to ask him some questions about it. And I want to play some clips from that interview for you guys here. So this is my interview with James from the YouTube channel Real Solar Cars. And he is out of all the various attempts that you've seen in the previous stages of this video, he is the only one to successfully charge the high voltage main battery directly off solar. So I wrote down a few questions that I'm going to ask him on how exactly he pulled off that magic trick. But before we dive into that, James, what's your background and what got you interested into trying to make your Volt solar powered?
So, my background is in electrical engineering. I've been interested in electric vehicles for a pretty long time. The pricing was just kind of out of my reach or so for a while, and then I noticed it's like, oh well, I could buy one used for like 10,000 or something, and of course, so I live in New Mexico where it is quite hot and sunny, and I thought, instead of just putting up a regular sunshade, could I put up a solar panel instead? Instead of letting all that solar energy go to waste, so I, just did some quick calculations, and I think I ended up like 10 miles a day or something. It's like, oh, well, that's pretty good. That looks like a project that's worth doing.
Yeah, for sure. And your proprietary device, I'm going to take some pictures from a few of your YouTube videos and probably splice them into the video here so people can get a better look at it before they go check out your videos. Your charger in this picture is connecting directly to the car's high voltage battery?
Yeah, I have it. Basically it does the pre-charge and operates the contactors as closely as to the vehicle's own systems or so as I could get. So basically it's the same procedures and stuff, that it's just being controlled by my circuit board instead of the car's own electronics.
I know another YouTube channel, Power Electronics blog, does the I think exact same thing you've done, where he kind of tricks the car's contactors into closing when he wants them to, but instead of using solar panels like you're doing with your Volt, on his Leaf, they close and connect to a second auxiliary battery that he's tucked in the trunk, and basically have the contactors close only when those two batteries are connected. But with your method, whenever you want to apply that solar power, you tell the contactors to go ahead and close even though the vehicle is turned off.
Yeah, so the thing is, like, so basically, yeah, I do the solar charging while the vehicle is mostly turned off. So, I power up the battery management system in order to get a voltage reading from it. Of course, then I have to power the contactors in order to be able to actually charge the battery. I got to make sure that the rest of the system, as many other systems as possible are kept powered down to keep the overhead, the consumption low.
Yeah, you can't just leave the car turned on, because the regular vampiric load on the vehicle when it's turned on is more power than you can make with the solar panels. So you have to kind of tap into the system and only selectively turn on the contactors and the BMS, and that way you've limited your vampiric drain on the system. Awesome.
Yeah.
And so that's how you resolve the contactor burnout issue. That was going to be my next question. The heat buildup under the hood. I know the Volt has an ice engine too that clicks on from time to time, which means it's got to get pretty warm under there. Is that a issue for the electronics that you've placed under there?
Yeah, so if I have ran the engine or so, like, I will, kind of probably open the hood a little bit more and, try to let it cool down a bit before I turn on my converter. The converter does have a cooling fan on it now that it was not seen in the last video.
Okay.
Just because, like, it's getting over 100 degrees in the summertime here. I want to have the converter continue working or so instead of stress testing it and destroying it.
And I'm sure you'll continue to figure out other ways to stretch out the longevity of it. What's your record miles per day that you've added from, or kilowatt hours per day that you've added from your solar system?
So my record is 2.09 kilowatt hours. So, and that is 2 kilowatt hours, 2.09 kilowatt hours net into the high voltage battery.
Okay, so 2.09 miles. The Volt, I think, gets around somewhere around 4 miles per kilowatt hour. So you're getting probably around 8 miles a day off your solar panels.
Yeah, I guess I did some calculations and thought that that seemed to scale pretty well with, like, compared to, like, the size of your array too.
Yes. Yeah, I've got you've got 400 watts of paneling, and I've got about 750. But my several of my panels are oriented, like one of them goes on the windshield, one of them goes on the hood. They're not, the angle of them all is not optimized to the sunlight as they are on your Volt. So you're not going to see a total scale from your 400 watt system to the 750 watts that I do, because my angles are not optimized on some of mine. But taking into account that, yes, the 2.09 kilowatts for you versus the, I think I got 3.2 kilowatts is my record, right around there, does scale. And we're at a comparable latitude as well. So that it all lines up. It makes sense. Okay, well, James, what are your future plans? I'm sure you're not ready to toss in the towel today on building solar cars. What are you hoping to do in the months and years to come?
I'll be redesigning the converter, so this is just the first version, just to prove whether or not I could do this without upsetting the car completely, which was a concern. And what I would like my converter to be able to connect to CHAdeMO ports.
Okay.
A lot of EVs have CHAdeMO on, and that would be a good way to charge it or so, or you can get like a vehicle to home device that connects to CHAdeMO, so like you don't have to charge at 600 watts. You can actually discharge from that port too, so it should be able to support lower power charging from a solar array.
Okay. And if you hooked it up to a CHAdeMO as well, your system can work for people who want to charge their cars using the CHAdeMO port, and they don't have to tap into the high voltage lines in the manner that you've done.
That would be a really good thing, or so, to be able to just plug a system in like that and not have to worry about connecting the high voltage lines.
Yeah, for sure. I know there's one of the reasons I started out with my system the way that I did, as opposed to going straight to jumping into the 400 volt lines, is that 400 volts can be dangerous. It's definitely intimidating. And I wanted to start out with something a little more user friendly, but eventually kind of evolve toward the more efficient system that you have, where you get an extra like 10% bonus because you're not running it through two different inverters the way that I am. But okay, man, that's all the questions I had for you. Thank you for showing us your system. And you, like I said, you're the first person that I've seen connect their solar panels directly to the car. There's plenty of people that have done it using the method that I have with running the solar panels through the J1772 plug. But you're the first person to tap straight into the high voltage battery, so congratulations. I'll tap my hat on to you on that one. And guys, swing by and check out the YouTube channel Real Solar Cars, and heckle James if he hasn't put out a video in the last month or so we can keep some pressure on him to keep working. All right, thanks. So that's it for my interview with James. One of the things we talked about that I edited out of this video was how hard it is for us as amateur YouTubers to stay motivated and share our inventions and videos that take hours or all day for us to make when they don't really get any attention, and only like 15 people wind up clicking on them. I've gotten a little bit of traction with my channel, and I am going to try and imitate James' creation for the Leaf. My wife is spending about an hour a day learning circuits and electrical engineering, so we can potentially create a commercially available solar leaf kit for around $1,000. But honestly, the person with the skill set to bring a product like this to market is James. I mean, he's got a master's degree in electrical engineering, and I've got a high school diploma and zero free time. So if you want a solar charging station for your Volt, or your Leaf, or your electric smart car, the best thing you can do to make that happen is to go to his channel and hit the subscribe button and sound off in the comment section. It really motivates us more than you know. Okay, that's it for today's video. Let's check out the economy V's of the week. The first economy V of the week comes to you from Houston, Texas. Never pay for gas or oil changes again, or worry about finding a parking spot with this electric smart car. The electric smart car has active battery cooling, so it will stand the test of time, and this economy V will only set you back $3,000. It's a perfect commuter car, and for most people it will pay for itself in 2 to 3 years in gas and cost of ownership savings. The next economy V comes to us from sunny San Jose, California. This always garaged 2011 Leaf was on sale for $4,500, which is a little steep, but somebody tipped the seller off to the fact that the 11 bar battery in this car is a very rare find. The Sun Eater was able to get 53,000 miles and counting off its first battery, so it stands to reason that if we took the battery out of this Leaf and put it in the Sun Eater, we could get another 53,000 miles at least off the new battery. It was too good of a deal for me to turn down, so I bought it, and this Leaf is on its way from Cali to Texas as I'm recording this, and we've got some big plans for her. We're going to take the battery out of this Leaf and put it in the Sun Eater and try and do a full tutorial video on how to do a Leaf battery swap. But after I drop the battery out of this economy V, I'm going to have an extra Leaf on my hands. So what the heck am I going to do with that? Well, I've had a project in mind for a while about trying to build a giant solar power wall on wheels and hook it up to one of these Leafs to give it a range of like 150 or even 200 miles, and have the power wall be detachable so you can separate it from the Leaf and still operate the Leaf. I don't want to go into too much detail on it because I'm one of my next few videos is going to be all about this project, but It's going to be a pretty crazy build. I don't think anybody's ever done anything quite like it. And I'm going to try and fund the whole thing with raffle tickets that I'm selling on Kickstarter, so you could actually win this build when I get done with it. And tickets will probably be like $20 or something. So anyways, that is it for today's episode. You guys have that to look forward to in the next couple weeks here. Thank you as always for tuning in and for the support, and I'll see you guys next time.